Before going to the IoT, let us have a close look at what made this IoT possible and what are the premises in which IoT is now developing. Let us look at a small computer. It's called Apollo 11 Command Module, 1965, but developed in 1965. It is actually used for the Apollo 11 mission into moon. Why now a lot of people are talking about IoT? Okay, so the basic idea is that microcomputers got cheaper and more powerful. This is what I want to emphasize in this slide. You can see that Cray-1 processor. It developed in 1975 and it has around 80 million floating point operation. It can do 80 million operation flops basically. And 10 years later we have Cray-2. It just can do only 1.9 gigaflops, but the iPhone 5s that in your hand can now do 78, around 80 gigaflop per second. This is how the computing power is getting advancing much faster than we can imagine. Okay, so this is what our very humble Intel 4004 developed in 1971. It has around 2,300 transistors. It developed with using 10 micrometer technology and primarily used in calculators back then. Okay, it has around 740 kilohertz. You may be knowing that this is first commercially available microprocessors from Intel. Okay, and from there onwards, microprocessors has been developed very aggressively. Maybe you can see the power in the graph in which the computing power has been increased considerably. Maybe you know that there is something called a Moore's law coming in play here. You can see that from 1986 onwards, the percentage of growth is almost 50% year to year. Every year we are increasing the computing power by 50%. This is how it is keep on going. Okay. This is what the Moore's law says about. Moore's was very famous in the semiconductor industry and is actually given by one of the founder in Intel itself. It says that the number of transistors that can be placed inexpensively in any semiconductor devices, say microcontroller, microprocessor, okay, whatever it is, can be doubled approximately every 2 years. Okay, this is what we are seeing in this graph. Basically, this was more predicted long back in 1970s, and a lot of advancement in the semiconductor technologies has made this Moore's law possible. Still continues. What you are seeing here is recently in 2017, NVIDIA founder Jensen Huang revealing one of the most powerful computing devices ever made by human. This NVIDIA Volta GV100 is boasts around 21 billion transistors, and it has around 5,120 CUDA cores. The CUDA is one of the proprietary architecture of NVIDIA. And what we have to understand is that this is how the technology is advancing. What Jensen holding in his hand is actually a supercomputer. Okay. And there are a lot of inventions and innovations happening recently in IoT. So you can see a lot of IoT hackathons are happening around the world. You can see IoT hackathon from Nordic countries, from Stuttgart, Germany, and India. You can see a cash prize for 50,000 rupees, something like that, and from Zurich, from Switzerland. A lot of hackathons are happening. Okay, so just to give you a glimpse of what kind of products are developed as part of IoT. This is what an example I took it from the Australian IoT hub. Actually, you can also check it from the website iothub.co.au. They recently, one of the first Australian IoT awards. They made some kind of a competition, and some of the finalists I am noted down here. You can see what kind of products now people are after now. You can see one of Monsoon IQ pump set booster system. a cloud-based system that provides some kind of real-time connectivity to their water usage, and some salmon farming something. And another is sensor for aquaculture, a cloud-based platform that collects real-time water condition data from sensors and convert into some kind of weather and water quality. And basically it is using for oyster farming industry in Australia. This was actually even featured in one of their newspapers, this invention. So oyster farming is one of the complex things in Australia, because oyster farming is very complicated. It needs some kind of very specific weather conditioning to farm very economically and profitably. So basically IoT is now helping them to predict basically the weather condition and the water temperature and all. So they are putting a lot of sensors and collecting the data and doing the back-end work in some cloud and sending back to farmers. So these are some of the finalists in the IoT awards recently happened in Australia. So maybe I want just to give you a glimpse on. Okay, this is how some IoT devices really look like. You can see some blood monitoring system. Okay, so you maybe already have seen all these devices. These are normally embedded systems. So what makes up them as an IoT? This is what we are going to see. Okay, so there are small devices. What are the promises of IoT? Okay, Gartner, one of the business consulting firm, they are predicting almost 26 billion devices would be connected to the internet by the year 2020. That is almost very near. Okay. And some organizations like ABA estimate that more than 30 billion devices will be wirelessly connected to IoT by 2020. Whatever the figure, may be varying bit, but whatever the figure, what most of the management consultant firms in the world are predicting a huge growth in the IoT area. So because of the now the connectivity also getting better and better. Now we have most of the cities now in India also have 4G, and some of the countries we are 5G also now advancing. And so that also, say for example in India itself, with the advance of Reliance Jio and all, now the internet is getting cheaper and a lot more places are getting covered in internet. So the network connectivity is getting cheaper and wider, and also the sub-computing power also getting cheaper. So these are the two driving forces in the IoT. So a lot of new areas are now we are adding computing power to IoT. Okay, this is something I took it from Alliance for Internet of Things Innovation. This is a consortium in European Union. Okay, so basically they have created a consortium itself to advancing the technology in IoT. They have predicted that almost something similar, 20 billion IoT devices will be connected by the year 2020. And look at the revenue. They are predicting some 7 billion in 2013, and predicting more than 1,000 billions in 2020 from the IoT revenue itself. And you can also see some of the areas they are seeing that has most potential growth. Say, one interesting figure is here, 1.3 trillion tags or sensors are going to connected in the world. Okay, so from where these tags and sensors are actually coming? You can look at the definition of IoT now. Hello, yeah.
What is the tag means?
Okay. Hello, yeah. A tag is actually a sensors. Normally, why we call tags are because they are so small. You can maybe put it inside any devices, or you can even stick it in your hand or like that. So basically, you can see you can see small devices like this.
Yeah, let me explain you what is a tag here. Tag is nothing but, for example, you are using Apple Pay. To pay any financial, that's a tag that you are using with a small device called iPhone.
Oh, okay.
So let's say we are going to Walmart, for example, we don't need to pay, swipe our card now. We can use our Apple Pay or Samsung Pay. That's a
Okay.
tag.
Okay.
That
Got
means
it.
you're paying using a small device.
Got
So
it.
in
Thanks.
the screen, one slide there above, he showed a device called how to check the blood sample with a small device. So that's also called as a tag. So there are a lot of small devices right now in the world you are using for each and every areas. So
Okay, so this is what we are discussing about the financial implications of IoT. A lot of companies from almost all the domains, from consumer electronics to automotive industry, are investing in IoT. From majors like Robert Bosch, um, Continental, even automotive space also. So you maybe know that Google also having some project called automated car driving. So even they also connecting a lot of devices to internet. Okay, so I will also discuss this. Okay, and what is the definition of? Okay, so basically it's like interconnection of embedded computing devices and within the existing internet infrastructure. This is maybe some good definition of IoT. And also, unlike our normal internet, there are a lot of machine-to-machine communication also coming in the case of IoT. And another difference is that some of the protocols that we are currently using in the consumer market may not be suitable for IoT. So we'll also be discussing some specific communication protocols that are exclusively developed and used in the IoT domain. Okay, so some of the challenges in IoT communication is that normally we'll be working with some devices that are spread across some vast area, maybe acres, or say for example in the case of agricultural products. Recently I also involved in one of the agri innovation projects for IoT, and what we developed was small nodes, IoT nodes that will be planted in the fields, and this device will collect a lot of data like humidity and condition of the soil and all. So it will send it back to some kind of server and will be analyze this data backend and push the information into some kind of a app. So here the problem is that the devices was actually planted some 100 meter, 200 meter or even kilometers away. So the communication communication should be so vast. So we are using some kind of a Zigbee, some protocols like that. So, and what is a thing? So we know that IoT is Internet of Things. So this is one kind of a definition.
Project you described it, right? You're
Yeah.
working or you work, but the seeds you're saying that, so the seeds has the capability of collecting the data, and that's what it sends to the device. Is that what right understanding?
It's not about the speed. That is a major difference in the IoT now, because
Yes.
normally we won't be transmitting that many data. So speed is not that much, because actually we want to get it transmitted over a big or various length. Say for example, I told you the device that we implanted actually spans across some hundreds and 200 or beyond kilometers. So range is more important. The data that we are transmitting may not be that much huge, maybe some bytes or even kilobytes only. Say it may be transmitting the humidity condition, soil condition, and temperature like that. So the
Yeah.
data is not that huge. Yeah,
No. I
but it
think
should be. Yeah.
no, Akash.
Yeah.
My question is the implants, the seeds you said, right? If I
Yeah.
had definitely correct my place. So the
Yeah.
seeds you planted, like in the soil, that itself
Yeah.
has the capability to collect the data. Is that correct?
Yes. It has the capability for collect data and also send it back to the server.
Okay. Okay.
Yeah. This is one of the agri project now we are working. Okay. So that's what I'm saying. So normal protocols like Wi-Fi, right? Wi-Fi have high bandwidth. but not that much coverage. And also Wi-Fi is a bit costly in the terms of semiconductor cost and power consumption. IoT normal Wi-Fi is not suitable for an IoT device because first of all IoT.
I understand little bit. Like I think I didn't understand when you say machine-to-machine communication. You are talking about once collected that data, whatever the sensors or tags, which sends the information to some servers. So is that what you're calling machine-to-machine communication? And again, there
No,
are
no,
other
no, no, no.
components.
That is no. Machine-to-machine communication is a bit different. That we have not discussed. Right.
Okay.
Okay. Yeah. So this is something different approach actually. Machine-to-machine.
So,
Okay.
so in short, if somebody asks, right, what is IoT in layman terms, what we can say? How do we say in simple terms?
Okay, so we can give some examples like to make our existing home appliances smarter. I'll give you one example. Say for example, our home. There are a lot of home automation you're maybe hearing about, right? Home automations are example of IoT implementation. Say for example, home temperature or the status of the lights and home appliances that are playing now. So all this information we can connect it and put it in a server, or maybe maybe we can also make it available in some kind of an IoT, maybe it's Android or iOS app, so that the home owner can understand the status of his house remotely.
Okay.
Recently, one of my friend actually came to me discussing some typical problem. Say, for example, in these bore wells.
Yeah.
Right. In some places in India, we normally use bore wells for getting water. So there's one problem with the motor in bore well is that if you don't use it for a while, the motor will get damaged.
Yeah.
That means every week we have to at least switch on this motor, borewell. So what happened is that my friend actually he went abroad for 6 months or so. So what happens when he came back, this borewell was almost damaged. So now he has to invest another 20 to 35,000 rupees to repair it. So a simplest solution is that maybe it won't cost that much, or maybe 500 rupee, we can put a small electrically controlled switch and a small Arduino or maybe a Raspberry Pi along with the switch, and put a subscribe also a small less data SIM connection, and remotely we can switch this motor on from wherever he is in there. So with just an investment of some 100 rupee, we can save some 30,000 or maybe more than that. A simple example.
Yeah. So that means instead of physically you're starting the borewell motor, you're saying that send some kind of a command. When it invokes, it means it's running, right? That's what you mean.
Yeah, exactly. It can be a simple command, or it can be in a small app, Android app.
Okay.
Yeah. So this is very much possible. Yeah.
Yeah. So another thing, right? Your agriculture project you are working. You said the IoT and the servers and the data collection. So again, it looks like IoT and big data is kind of more like even independent, but I think more useful together. Is that correct? Is right understanding? Because IoT is the
yeah, you are partially correct, because IoT is not necessarily using big data. Actually, big data and IoT are bit different technologies, but there are now a lot of interest coming in merging IoT and big data. You should understand both separately. IoT doesn't say anything about big data. How you're handling this data is completely up to the user. Maybe you can use some big data techniques for analyzing the information. So big data normally comes when we have billions of data, so that manually figuring out this information is virtually impossible. So big data is normally billions of data. Say for example, this makes sense when, I'll tell you one good example of IoT and big data. Suppose uh, we are employing this IoT in cars. There'll be, suppose we are manufacturing millions of such cars, okay? And this car will be collecting a lot of data, the information on how fast it is driving and what are the problems in the tire, in the body control, engine, lot of data. So millions of cars generate, say, millions of data. So over in a year, it will be maybe terabytes or petabytes or what more. We don't know how much it will be. So it is not at all possible for a human being or even a machine to understand, to figure it out what this data means. This is where now big data is coming into picture. And big data can make actually, big data, the whole idea about big data is make sense of the data. They're using a lot of algorithms. And one of the problem or one of the challenge in big data is that it needs a huge computing power. So I mentioned in the very beginning that one reason actually all this big data and IoT are coming now because of the cheap availability of computing power. So normally big data analysis, we need some powerful machine. This will start crunching this information that we are collecting from the IoT devices and make sense out of it. So how big data is, even I also a learner in big data. Big data is more about algorithm and how you interpret the data. So it doesn't mean that you should use big data. Okay, IoT is completely different. IoT is now connected embedded devices. So IoT is more about how to make our normal appliances smarter.
Okay.
So one example I already told you, how to make our motor pump now smarter. So imagine a motor company is now introducing some smart motor. It can be controlled remotely.
Yeah, got it.
So maybe 1,000 rupee addition, it doesn't make much sense nowadays, right? I mean, it makes sense. Just additional 1,000 rupee, he is making a lot of new features, making available to the customer, and he can save, say, tens or thousands of rupees. Actually, this is now coming as part of a home automation protocol. So it need not be a separate, device. So normally, if your home itself is completely networked using some protocols, there are a lot of protocols for home automation, and this particular switch we can plug into this network, and there need to be only a single gateway for the entire home. So it may be your motor pumps or light, fan, our security cameras, everything can be connected to a single network and a single gateway, and this gateway we can connect to the internet. So this is how normally home automation works. So it doesn't like each individual devices communicate directly to the internet, and also it may be a bit costly also. Is it clear?
Yeah. Yeah.
Yeah, no problem. You can always ask question. So this is what is mean by things. Okay, so IoT is Internet of Things. So the things, we have already seen some of the things. It's like heart monitoring implants, biochip transponders, annual prams. Think about anything. So, and there are, okay, another driving force in IoT is innovation in sensors. Something that I didn't focus much. Okay. And there is a lot of innovation happening in sensors, and virtually it is possible to sense each and every biometric or physical data available. Say Bosch, ST, a lot of companies are making a lot of innovation, and good thing is that most of the sensors are now getting cheaper and cheaper, and we can put all the sensors in a single devices. This is also one of the innovation. So one example is that, say, I have seen one IoT innovation product that is actually measuring our mental stress. How it is doing is that
what is that?
It can measure it can measure our mental stress. Mental stress, our mental stress, psychological stress. Yeah, mental stress, psychological stress.
Okay.
How it goes is like they have found that our body skin resistance is a kind of a proportion of our mental stress. Some study found something like that. So what they have made is they have created some kind of a stickers, and we have to stick this sticker into our skin, And then this skin is something, actually measuring the body resistance, and they measure the body resistance using this sticker and do some kind of an algorithm and analysis, and finally we'll get some kind of a parameter or some indicator how stressful we are.
Wow.
Yeah, this makes happen only if advancement of sensors. And okay, if I am talking about future, there are even innovation happening about brain to machine communication. Okay, that is something weird. It's not still commercially available. There are some people who are working on directly communicated from brain to devices without even using any external inputs devices like keyboard, mouse, something like that. Basically, they're interpreting our EEG signals. Like EEG signals now. Something when happened to our head, we are doubting, we go to hospital and take EEG signals. Basically, EEG signals are giving some indication of how healthy our brain are. Actually, this EEG signal can also used to interpreting our thoughts. That's why some people say. And they have created some demo also. It's not only in dreams. So basically now, this is what now they are handling. Even Google also are investing a lot of, not on Google, like Facebook is investing heavily on this technology, mind to machine interfacing. That's what they're saying. I don't know where they will.
So seems like in this technology, even India especially is also advancing, right? I mean, from the resource perspective.
I doubt there, because all this IoT and the sensor technologies are heavily patented.
Okay.
Yeah, because the company that I am working is having patents in almost all the areas in the sensor technologies, and it is virtually impossible for anybody to manufacture them.
Oh, okay.
Yeah, so that is the case. So even though if you have the technology, hardly even we're able to commercialize it because of the patents and other copyrights issues. So, but India has a huge potential for IoT market. That is very much. Say for example, agri. Agri is one of the huge area. Agri has huge potential in India for growth. Because right, actually in India, agriculture is not at all modernized, and there is a huge potential for laying out IoT infrastructure. And there are some people who have already made it happening in North India. They've already demonstrated some 20 to 30% of profit using IoT. And actually the thing is that compared to some 10 to 20 years back, the components that we are using are much cheaper. Just I've told you, the some electrical connection and everything, just cost some 500 rupees only. With less than 500 we can do it. Even suppose we are doing it mass manufacturing, maybe the 50 rupees or 100 rupees we can manufacture it. So the same case with agriculture. A small chip that we are using in this device is actually very powerful. It costs only some 50 rupees. That 50 rupees chip can do much more than what a computer does in 15 years back. Okay, so more than enough. So that's what actually the computer chips are getting much better and cheaper. We can computing is actually, you can regard as free. It is nothing. Nobody is considering the cost of the computing now. It's nothing compared to the business value of the business actually value we are adding to the product or service. Okay, so I'll move on. Okay, so I am concluding what are the things now we have discussed so far. Okay, so basically in the initial stage of the internet of things, people are getting connected to things. I just mentioned like some kind of stress measuring device, right? Basically, you can see some kind of like ECG sensor. Okay, ECG sensor, I think still there are a lot. It's already commercially available. That is used for heart patients. So it continuously monitor heart health, and something went wrong, it even messages, call relatives, like that. So it's already available, commercially available. Motion sensors are already commercially available, and all of them. Most of them are already commercially available devices. So basically, these are people getting connected to the internet. Okay, And then you ask me, what is the thing to thing? This is actually mean by machine to machine communication. Things are getting connected to things. Okay, so here we are employing machine to machine communication. You can see information from petrol bunk is going to car. So one use case would be say in the case of an automated car, the car can directly go to the petrol bunk and fill fuel and go. So this kind of scenario they are actually envisioning as a machine to machine communication or things connected to things scenario. And this is another area like wireless sensor networks. So just the one I have given you, like the agriculture project. Basically, we are using a wireless sensor network. You can see the small green dots. See, these all are called nodes. Okay, and we have something called a sync node. So basically, the sync node consolidates so many other nodes, and then finally it gives to gateway connected to the internet. This is how normally most of the IoT infrastructure works. At the end, there will be IoT nodes, we call IoT nodes. The nodes will be communicating each other, and finally it will be connecting to some sync node, but sync node is optional. Sometimes we directly go to this gateway, and gateway communicating to an internet or some other wider area network. And this internet will again maybe connected to say server or through some other gateway to other IoT devices as well. And ND devices can access the whole information through some app or using a computer. This is a basic infrastructure in the IoT. And okay, I also want to give you a big picture now. You can see the blue dot. Okay, the blue dot are actually the devices or the things that are now connected, that were connected in 2003. And the brown circle is actually human or people. So what is predicted? You can see by the year 2020. Actually, humans are not growing that much. So the brown circle is not grown that much. But you can see the blue circle. The blue circle has grown much, much more. So this is what people are predicting, the impact of IoT. Almost 50 billion connected devices by the year 2020. Okay. So what we should learn about IoT now? So I am also consolidating that link. What are the emerging technologies? What are the various areas where IoT is now utilizing, like smart cities? So you may be knowing that central government has declared some 100 smart cities in India, and many IoT companies are now actually participating in the smart cities project. IoT is actually, there are various layers in IoT. I'll be saying, for example, in the very lower layer, we are talking about embedded systems. Okay. Embedded systems are connected to devices. Say, for example, these are normal embedded systems. Maybe we can do some hands-on with Arduino or Raspberry Pi. And going up, we'll be having some communication stack, and finally will be cloud. So IoT is that much vast area. Even I also not much, expert in the whole area, because there'll be very few people who will be working all these areas. Some people will be concentrating on the node side, some people will be on the architecture and the communication side, and some will be on the cloud side.